Okay, so let's get back. So last time we introduced 4 loops, and we will get back to the loops again, but I'm just gonna introduce you to some more tools that basically help control your program. So if we go back to the example, I think all of you have some function, however you decided to name it, that computes area and perimeter of a polygon. If you don't have a function in front of you, well, this is one way to do it. This one actually just takes the side length S as a parameter as opposed to the radius. That's up to the person programming and designing the problem. So basically there's this first part of the function that is in green. It's commented. It has those little percentage signs at the beginning of the line, so that means that that's just a comment. It's not going to get executed, but it helps you know what's in the file. And specifically, if I say help polygon, then basically that's what's going to get printed on the screen, so I know how to use the function and what the parameters are. And there's input parameters, there's output parameters. And then the main part of actual computation are basically these lines here. I could have chosen just to say A is equal to this formula instead of forming another function, but if I want to code to be more readable, then I could form this sub-function. Yes?
Why did you make those empty lines comments?
Empty lines?
Yeah, like lines 8.
So it's pretty.
It would be the same if you just had it without the comment.
So there's an empty line here, right? Again, it's just so it gives the spacing, so it's some sort of formatting or very rudimentary formatting, okay? So I'm just leaving a line so it's easier to eyeball what the information is in that paragraph. Okay? Again, it's up to you what you put in there and how you organize it. This is one way. Okay, so now here's one question. Can somebody execute, could you execute for me? Do you have a function that you programmed? So we programmed the function that is for polygon. Okay? What happens if you type in polygon of 1, 1, where side length is 1 and n is 1? You can all try it with your own function. What do you get? Yeah? Does that make sense? Does it make sense to ask area for what happens if you put side 1 and n is 1 or n is 2? So in both cases I have a polygon of 2 vertices, whatever that is, however it is if you want to visualize it. Does it make sense for a polygon to have? What happens if you put in s is -1 and n is -1? So you execute polygon of -1, -1. What happens?
Just give me the negative version of 1, 1, but really small distances here.
Well, in both cases, those things don't exist. We're talking about polygons, right? So the problem is that the function is going to compute something. That something might or might not make sense. Okay? But if you're actually executing this as part of a batch, so it's going through like 3,000 points of some data, you don't want those garbage numbers in there. They're going to mess up the execution of the rest of your file, and maybe those ends are in there is a mistake. So you need a way to flag that. Okay? And the way you would do that, okay, you would say, well, okay, do this entire calculation only if n is larger than or equal to 3. Right? Otherwise, just print an error message and return zeros as numbers, but say something. Okay, something's wrong. Say something. So those type of if this then do that. Okay, that there's a loop, or I don't know that we're going to call it a loop, but it's basically a direction in the program. So we are now going to learn the operators that basically allow us to direct our program in one way or another, because we want to catch certain mistakes and avoid basically computing garbage. you can have the most advanced algorithm for computing something, but if your input is garbage, your result is garbage. However fancy your algorithm that is working on that garbage data might be. Okay? So we do not want to do that. So those operators that actually help us, we actually went through input. These are just some helpers here where you could actually ask for input if you wanted to. And we already did the display and a display function last time. So and formatted output we did last time. So the operators that actually help us are called relational operators. So let's actually do just some small practice in your MATLAB. I can work with you. So basically they're going to have a so-called logical value or value 0 or 1. Today's 18th? 19th. Ooh, I'm behind. So let's give myself two numbers. A is 2. B is 4. Okay. So I can actually define a variable. A is smaller that is equal to, this is this relationship, A less than B. So this less than is a relational operator. Okay? So basically the result of that is 1 because 2 is indeed less than 4. Okay? If I actually turned it around and said B less than A, that is not true. Not true in computer language is 0. Okay? So I can have 1 or 0. A is smaller is 0 means that, well, A is not smaller. Okay? And if I wanted to actually do something as a result of this, then I can say, well, if A, I can name a variable, or I don't have to have a variable for it. If A is less than B, then display A is smaller else, so otherwise, just like in language, display B is smaller. And end is going to, note that I'm putting commas, probably needs semicolons, just because I'm actually dumping everything in one line. Okay. So what you can actually do, we can open a new script and say A is 2, B is 4. And if I was programming this, then I would actually give it a little bit of different lines. So I would say phase B, display, else, end. So this is kind of nicely formatted, so it's easier to read than everything in one line. So it's pretty much what it is. So if A is less than B, then I can have much more code than this. I could actually go into some computation here. Say C is A plus B. Okay? So that will compute some variable C that might mean something to me. Otherwise, display B is smaller and compute C is A minus B. Okay? And there could be as much code as I'd like here. And this is why I need this word if. These words, they're called keywords, if, else, end, to basically just put delineation. When is the start of this portion of code that I want executed and where is the end of it? Now, of course, there could be many other things that you could check for. This is only one relational operator. And this is the list of them. So there is less than or equal to, larger than or equal to. This is equal. So there is a big difference between just one equal sign or two. When I'm saying one equal sign, A is equal to 2, I am assigning 2, value of 2 to A. Whereas if I'm putting equal, I'm checking whether A is equal to B, or A is equal to 2. So basically I can say, I can execute these things is if A is equal to 2, okay? That means like an existing value of A, I'm checking whether it's equal to 2. If I put one equal sign, I would essentially overwrite A with 2. Is the difference clear? So as a logical, those are called logical operators as well. I'm checking whether something is equal to 2. And then I could have, again, different, this is basically, is A different from whatever value? So I can ask whether is A different from 2? And then if I had like two things, so now I often want to check not only that A is less than 2, but I want also A be less than 2 and larger than -1. Okay? So now I have to pile a couple of these relationships together. An outcome of each relationship is a logical value, 0 or 1. Okay? So if I want to combine those logical values, I need to use these logical operators. Okay? So what I would do is I would say if A is, this is actually wrong, equal to 2, for instance, and A is less than B, then do something. Okay? So I might actually have a number of these together. And this might be actually ampersand. If I wanted to combine them, I think I need 2.
Why do you need two?
So there is 2. So here there is 1 missing. This will actually change, quite literally change bits, bit by bit, with an AND operator. So 1 byte of data, we're going to get to that a little later. 1 byte of data has certain zeros and ones in there. 2 bytes of data, whatever is this variable that is storing. Okay. All of those bits are actually logical pieces, zeros or ones. They can only have 2 values. Okay. And I could actually go bit by bit and check whether something is equal to. Okay. So in this particular case, I'm going to have to put that note in there. This table is taken from a textbook. So, and is if I actually want to combine these 2 values together. So I'm going to save this as a script, relational operators. So this is basically just to overview the structure. So you have this if statement. If it's true, you will do a set of commands. If it's not true, you could immediately end, or you could have else and the number of commands. So this part over here, technically it's optional. You could go simply without it. And this is still fine, because you might not want to do anything if there's this else business. So this part over here is optional. The minimum you need to have is if something, do something, end. Okay? But you could also go if something else, if something, do something, if else, do something else, and. You can actually keep going. If something, do something, else if something else, do something else, else if something else, do something else. You could actually keep going. So for instance, let me see if I have that on a slide to be, okay? Before we do an example. So basically we say if there's some expression that you're evaluating, and then you do a number of commands or statements. Else if you have another expression, do something else. Okay. So basically you're gonna reach, and you can keep going like this as much as you'd like. Okay. Whatever makes sense for you. Otherwise you're never actually going to, the moment one of these expressions up is true, you will have actually never reach this part of the statement. Okay. So here it is an example, and we can actually type this in as an example. So you can have two variables, x and y. If x is larger than or equal to y, you will evaluate c as this. And then if you do so, okay, if x is really larger than y, you will execute this and go directly to n. You're done. Okay. But if this is not true, then you will go to the next line. So if it's not true, then you will check whether y divided by x is larger than 0. If it is, you're going to execute c as this. And right now there's nothing else here, so you're just going to end. Okay. And it might be that you will actually never compute c, because if this is not true and this is not true, you will just go to the end and you will do nothing. Okay? So let's type this in as an example, and then I'd like you to figure out what happens first by on your own. Figure out by hand what happens in these cases, and then type in the code and see that you understand what's going on. And I'm going to be typing in with you. So I'm just going to give myself two values of x and y. I'm not going to type in comments. Comments exist. And some of these things are obvious. I'm checking here whether y divided by x is larger than 0, because otherwise I wouldn't be able to execute logarithm. Yes?
Do you need 0.0?
No, you could just put 0.
Okay.
There we go.
Are you only including the else if statement to test to see if there's negative numbers?
Right. Because if I had negative numbers, c would be garbage.
Okay. But if x and y were always positive, you wouldn't need else if, just else.
Right, but you don't know that, so you're checking for it, right? Or you might know it now and then you forget about using the function only with positive numbers, and then what? And it's not even that they have to be positive. So I have x is -4 and -3, and y is -3. Y over x is still positive, so I can work with that. Okay. So what happens for -4 and -3? Is -4 larger than -3? No, so I'm not gonna execute the first C. And then I'm gonna go to the next else if. Is y over x larger than 0? Yes. So then my C is going to be log of 4 over 3. Okay. So check that that's indeed true. What if I have 4 and 3? 4 is larger than 3, so the first statement is executed. C is equal to 4 squared, 16 minus 3. And then I'm never going to go to the rest of the statements. I'm just going to go to the end and be done with it. And finally, if I have minus 4 and 3, first one is not true, first expression. Second expression, y over x is not larger than 0 either. Okay? So my C will just not be set, which is dangerous for various reasons, because you might, in the rest of the code, use C. So you can actually say just else, set C to something. C is equal to 0. And you might also want to say display warning C is 0, because that might be a problem. Yes?
Why is for number 1, x equals to 4, negative 3, yes, c equals to negative 0.287, and then it shows up in the command window, but the second one doesn't, where c equals to 13.
Uh-huh.
Right?
Why?
Why?
This suppresses output.
Oh, I see.
Okay? So this might not show up at all. I would just monitor it here. Yeah? Okay, that's a great question. So sometimes you want actually, before you kind of weed out all of the mistakes, you want to avoid typing these. Okay, so you can actually see everything. But then when you're done with it, you want to suppress outputs because it can get annoying, especially if there's a lot of it. Yes?
So the else is corresponding to the first if?
No, it's a succession. So there's if, then you're gonna go else if this exists, and then else is the last thing. But I could have had a number of other else ifs. Okay?
Oh,
So you could have as many as else ifs as you wanted to. And else is just, it's a catch-all for if nothing else happens, then just do this. Does that make sense? All right. If else is very important to get down. Okay? So, oh, okay. I went ahead of myself. My slides wanted me to do something else. So I was using display command. And here I could have done a little bit of more formatted output. So display command just displays text. If I actually wanted to print what those x and y were that are problematic, then I would have to use fprinted. So this displays warning. By the way, either x and y are both negative or x is less than y, because that might be important for some reason. And then print them as a formatted output. So this is percent means expect a floating point number, a real number, f. Percent is expect a variable, f is a floating point. So then you have to give that variable right here. And y is also a real number, there's right here. And slash n, what does slash n do? So it's just the prettiness of the printout. Okay? Yes?
How do we know when to use the single quotation marks? It seems like they come up a lot inside parentheses, but sometimes they don't.
Always. So so basically single quotation marks are a mark of text. So if you want to define a string to be printed, you use single quotation marks.
We also use them for things like changing data, setting data types, like the floating. Like when we import data.
This is going to be sort of a string of text. Okay? So what MATLAB will do with this, it says, this is going to be a string. That string is something I would have to type in that text. But I don't have that variable, I don't know what to type in. So this percentage is a command that will replace in this string, basically this text, as x. So after that, this string that is printed on the screen is treated as a string. It doesn't know it's a number anymore. Okay, yes?
What's the difference between fprintf and display?
So this is precisely what I was commenting on. Thank you for question. So here, I have only text, okay? But if I actually wanted x to be printed, and x is a variable, I can't do that with display. So display just displays a string that is just a text that is ready to go. Fprintf actually works with it on a dynamic, it's more dynamic. So it will change depending on x. So basically I cannot say, if I want to display x here, x and y, I cannot, there's no way for me to print out what x and y are. Okay? That I have to do with fprintf. So I'm just gonna say x is equal to %f and y is equal to %f, and I'm gonna pass them to fprintf. And fprintf will take those x and y, create a text from it, and print it for me. Okay? So in essence, what I'm pointing out to, computer has to know whether it's working with a number as a number, which is what I use variables for, okay? Or whether it's working with a text, in case it's like, print this in a human readable format.
Did you need to tab after your first %?
No, I just,
You
well,
just do it to make it look better?
right, if you do without, you can. Computer will do everything you tell it to. Whether that's good or bad, let's execute this. Did I ever go into this? I want actually 0. Let's see what will happen here. It's still not printing a warning. Let's see. Should have negative number.
Yeah, because aren't you still in your...
You have the semicolon.
Hmm?
In the function, you have the semicolon after the display thing. Is that why?
Fprintf should still print.
Isn't it because you're still on your relational operators from...
-1 is not larger than -76. Oh, now I put them. There we go. Okay. So it's on top of each other, right? So I want to give it some space. That's why I put a tab in there. And so next line, space. Okay? I could put a next line in between here. That's this. Okay? So I'm formatting it until happy. Then I can say, oh, well, I don't like this many zeros. So I'm just going to put 2.2. This is basically spaces before and after 0. Okay? And you can keep doing like that. That's basically how many decimal spots. So it has a default value, which is 1, 2, 3, 4, 6. Okay? And this one saying just put 2 after that. Now this 2, technically it's going to reserve 2 spots, but you might actually be printing 243 and it's just still going to print it correctly, regardless of you requesting less than it needs to. Okay. It's going to bail you out. So to me, what I really put in front, it doesn't matter, I'm really controlling the decimal points. The decimal spots after. Okay? Alright. So we have already introduced a for loop. Okay? There's a track here, or track we go and run in a loop, and we keep repeating the same loop. Okay? So that's a visual here for loop. Okay. There's another type of loop saying while. Okay. So it might be that in your program, so for loop is good for those loops where I have some sort of counter, okay? So I can say, oh, I'm doing something and I'm processing a file of students, and I can say, while number of students is less than 30, keep doing this, right? Or for the students that are basically 1, 2, 3, 4. So it's just like you would talk about. I can do something while something is true or something is not true, so I can evaluate a logical expression. Okay? Or I can say for this many counters, keep doing this. So just like you would in language, that's how you can program. Okay? So this expression can be any logical expression, and we have learned the relational operators, so I can check whether something is true, and if it's true, I'll keep doing it. The problem with this one is, let's do an example. I'm gonna create a new one, new script. So let's say that I have something like that. This, x is equal to 2. And then I'm gonna say while x is less than 4, do the following. X is equal to x minus 1. And then I'm gonna say, I'll print that x and go to the next line. And I'm gonna say end. So just from logic of it, what's gonna happen? So my x is 2 to begin with. And then I ask, is x less than 4? It is. What I'm gonna do? X is gonna become 1. And I'm gonna print it. And then I'm actually gonna keep doing. And I'm gonna ask again, is x less than 4? The answer will be yes. So my x will become 0. And then I'm gonna print it and keep doing. Am I ever going to stop? So the benefit of for loop is that it's eventually going to stop. I'm designing it to go from 1, 2, 3, 4 to whatever, but I'm gonna stop. Here, I could actually create an endless loop. So actually you can do it. Let's just execute this. So I'm gonna say loops. Okay. So let's, whoops. So two things. Actually, MATLAB said, okay, enough. I'm done with this, but it's hanging here. So you say put Control C. Control C will get you out of it. There's a mistake I made. I actually didn't print it correctly. I didn't give it X to print. So now I'm gonna do it. And you can actually see it was trying to warn me, but I wasn't listening. So if you actually put this, there is here a warning. The format string might not agree with the argument count. That's Greek for you're missing X here. Okay? So often you might not actually understand what is the warning trying to tell you. We'll just go back to that part and see if something might be wrong. Okay. So if I do it now, I'm still gonna be in the infinite loop, and I'm gonna keep going. If you're actually also in this loop asking for memory, if you're asking computer to get more and more memory, you're gonna crash your computer. Because you cannot go above 8 gigabytes, 16 gigabytes, or whatever it is that you have on your, okay? So if you're doing something that is asking for memory, you're gonna crash your, so you might actually just have, unfortunately, with all the advancement in this world, MATLAB is not set up to stop this loop, okay? And if I was asking for memory, I saw that happen a lot. Like this software is not necessarily set up to guard itself or the operating system from crashing. So you gotta be careful. Now the only thing you might shut down the computer and when you restart it, it's gonna end. So that's gonna be fine. Control C, and it's not stopping either. Control D.
If you have a for loop, are you able to change?
Okay. I'm gonna have to stop now and exit. There we go. Alright. So Control C, it kind of wasn't responsive to it. Control C or D should exit, but it didn't. I just lost my diary. Warning here. So I just lost that diary that I opened to data, the text file. Since there was no clean close of the diary, I doubt it's there. I can actually check for it right now. So this is a learning process. It's gonna happen, so you gotta be careful with it. So let me see if I have the diary here with this date. I have something, so it was smart enough. Let's see, type lecture. Let's see till when did it stop? So it was actually typing into that diary. And it was actually smart enough to close it. Okay. So in this case, pretty good. The diary is there. Yes?
Can you end the diary and then start typing the diary again in the command window or not?
You do diary off.
And then how do you turn it back on?
You just say diary. So if you just do diary, it's going to have a file called diary.txt, I believe. And then you just say diary off, diary on, diary off, diary on.
You say on it.
It's called toggle, yeah. It's called toggle. But if I now do it again, so the benefit of giving it a unique name is that it's not going to overwrite what I had before. Okay. So let's just give you an example. So diary, I'm going to say display hello. And diary off. So if I now type diary, diary dot, what did it name? Type diary. I'm just gonna open it. So just this, right? Now if I say diary again, okay, and then display howdy, diary off. If I open it, it actually added to it. So it's smart enough. This was changed, so it used to be that it just keeps overwriting from the diary. Okay. So you often have to actually check what it's doing because it can change it. All right. So it's gonna be keep adding to this same diary. All right. Okay. So again, we did already an example of for loops. So here is two more. If you want to execute them, you can. This is something very similar to what was done in homework. We did an example with x squared. But here is actually doing a sum of all of the elements in a file. I would create myself an array. Then I would set the sum. I have to initiate it with something, and that something should be 0. Okay. And then I could say for k is equal to 1 to the length. Length of x is length of an array. Okay. Keep adding. So this is take the old sum x, add the new element to it, and keep looping for all of the elements. Okay. So this is a classic algorithm how to do something in a loop. Or I could just do anything else. Here's like I could actually, it doesn't have to be 1, 2, 3, 4 in my loop. Okay. I could say, well, go from y This is going to be between 0 and pi, and every pi over 15. So there will be 16 numbers here. Okay? So for those 16 numbers, do something. That's fine too. Okay? And you can also nest loops within loops. Okay? So I could actually have a matrix. You all are a matrix. And I can say for each row, row 1, row 2, row 3, row 4, row 5, within the row, while you were working on row 1, go down and print all of the names in all of these columns. Right? And then move on to row 2 and print all of those names. Then move on to row 3. Okay? So I can nest, I will need a loop for going down all of these columns, and I will need a loop for going down all of the rows, and then I will actually cover this entire two-dimensional array. So for that, I need 2 loops. And I could, of course, have loops within more, like I have 3 or 4 or however many I want to nest. So actually, let's do this example. Okay. So basically, if I wanted to, where's my loops? So I'm gonna say, what's gonna happen to this loop right now? What did I just do? Just terminated it essentially. X, I set X to 2, and this the expression that I'm first evaluating is never, so nothing will happen. Nothing will ever execute. Okay? So I just effectively turned it off. So I'm going to turn off this one, and I'm going to create another one. Okay. So let's say that I'm going to give myself a matrix. Okay. How would I create an identity matrix that is like 3 by 3? What's the command? I. So I of 3. And then I'm going to essentially, I actually already know that I can compute matrix B as 2 times this matrix A plus 1. Okay? But I'm now going to do that element by element. Okay? So I'm going to say, okay, for I is 1 to 3. So this is going rows, and then go down columns. For j is 1 through 3. B of ij, so element ij is 2 times element A of ij plus 1. So I'm doing things element by element. And with my end, I'm going to end looping over columns. And with another end, I'm going to end looping over rows. Since my matrix is 3 by 3, I have accessed all of the elements of my matrix, right? 3 by 3. Because I will go for I is 1, this will execute 3 times. For I is 2, this is going to execute 3 times. For I is 3, this internal loop is going to execute 3 times. So that's 3 by 3, that's 9. So my B should be computed. Let's indeed see. So I'm going to do run loops. So I have A and B are showing up here. Okay. I can actually see them. It's small matrix enough to actually see, but I'm just going to display them. So my A is a matrix. And my B, it should be 2 times A plus 1. So this should be 2 times 1 plus 1. This should be 3. 2 times 0 plus 1, this should be 1, and so forth. So let's see. Oh, it executed things correctly. I could have just said again, C is 2 times A plus 1. And I would get the same. So this is called vectorization. MATLAB is already built in this manipulation of arrays and 2D arrays. But if it weren't, what basically MATLAB is doing while executing this, it's executing those two for loops underneath. Okay, so you actually know what's behind this. And most of the time in this course, I'm going to ask you to actually do that hard way, so you actually know what's behind the hard loop, so you can design the algorithms yourself.
I thought when we did functions, we didn't store our variables. So how are they showing up in the workspace?
So this is not a function, this is a script.
Okay. Yeah.
That's how. Great question.
So can you
So that's a little script. It's just as if it were executing in command. Yeah.
It's like lines and commands.
And I'm just storing them so I can use them later.
And last question. In a for loop, if we had it goes from like index 1 to 10, can we change that index within the for loop?
Yes, you could actually do for index. Index is 1, go every 2 to 10.
Okay.
So anything that you can do
Can we
with
say
these.
I equals something in the for loop?
So this means that I will first be equal to 1, then it will be equal to 3, then it will be equal to, so I is changing. But it's essentially assigning it these values.
Okay.
So this is a vector, right?
Yes.
This is a vector.
So we would never.
So what for loop is doing, it's assigning I to be one by one element of that vector. So you just give it any vector.
Okay. So there would be no reason for us to change the value of that vector
No.
from within.
So it's automatically changing. That's part of the for loop.
I mean, there's no like higher level reason for doing it. There's no application.
No. Okay.
I submit the little assignment